fairly large box. This is a eBay purchase. This is a Tenma audio generator. It's a 72455. It has a minimum output of 10 cycles and a maximum of 1 megahertz. We have an amplitude output here that's just variable between minimum and max. Then we have an attenuator that's either 0 or in steps of 10 up to minus 50 dB. Looks like 5.5 inches. I'll try to include the feed here. So including the feed, it's a little more than 8 inches. The box itself is a little less than 8 inches. And it is 10 inches deep. I think we'll just take a look inside. Looks like 1, 2, 3, 4, 6 Phillips head screws. They are machine screws, that's good. It's all metal case, metal back, front, and so on. It's all air inside. This is a capacitor driven by a right angle gear. Power supply, a couple of transistors. I purchased this on eBay. It cost me $60, $70. Delivery was real quick. I think I placed the order over the weekend and got it on a Wednesday. From this guy right here. One of the reasons I purchased this was because I could find a complete manual with a very well done schematic. What we have is a Wien Bridge Oscillator. It's got a current sensitive variable resistance device, which is a hallmark of a Wien bridge. Most Wien bridges use 2 rotating resistors, 2 potentiometers on one shaft with fixed capacitors. This design uses 2 capacitors on one shaft with fixed resistors. an oscillator, a buffer, and an output stage. We come out of the final amplifier down into a attenuation stage, straight through, or 10, 20, 30, 40, 50 decibels of attenuation. It has a fixed power cord, not a plug-in cord, which sort of dates it. I don't know if I'll be able to find any date codes on this. The only date code I can find is on this bridge rectifier, and it's the 14th week of 92. So this is 30 years old. I have the generator powered up. I've got it set on times 1K. Amplitude is maximum, zero attenuation. This is a 600 ohm output, and I've marked this terminal black to remind me that it's referenced to ground. We're at 100 on the dial times 1K, so it should be 100 kilocycles. See, in the oscilloscope it's 102, and the output voltage is 7.2 volts RMS. 7.3 volts, 9.9 kilohertz. We'll go the whole way up to 100 kilohertz. See, it's at 99.6, 7.2. Take it up to 1 megahertz. We've dropped down to 6.2 volts. We've lost a whole volt going full scale. We're 987 kilohertz. Go down to the times 1 scale, which should put us at 100 hertz. There's our 100 hertz sine wave at 7.2 volts. Take it down to 10 hertz. There we are, 10 hertz, 7.3 volts. So it is doing pretty well voltage-wise. Look at the square wave. Nice square wave. We'll go up 10 by a factor of 10. Work our scope magic. So pretty nice square waves. Calibration is accomplished through these holes in the side. Okay, we get the first calibration just by loosening the knob and setting it to a certain frequency. This is using a frequency meter to establish. Then we do 10, 100, and 1 megahertz using these 3 holes on the side. So we set one frequency just by adjusting the dial. Then we do 3 more ranges through these holes. There is this manual and perhaps some other information in the subdirectory listed below. So I think this will make a nice addition to my shop. Thank you.